Hopefully everybody can hear me. If not, hopefully they can read this and try to get the sound working on this video. This is a lesson on section 3.2, that's chapter 3, section 2, out of the chapter 3 study guide for geometry. The first postulate here is called the corresponding angles postulate. It says that if two parallel lines are cut by a transversal line, that's this one. We talked about parallel lines and transversal lines in previous sections, that the corresponding angle pairs are congruent. So there are actually 4 pairs of corresponding angles. In this intersection, in the upper right hand portion we have angle 2. In this intersection, in the upper right hand portion, we have angle 6. So those two are called a corresponding pair. We have several more. We have this angle here matching this angle here because they're both in the upper left hand portion of the intersection. We have this angle down here and this angle down here being a corresponding angle pair because they're in the bottom right hand portion of the intersection. And then this one and this one would be the last pair of corresponding angles. So what this postulate is saying is that any pair that you can see are corresponding will have to be congruent. So for example, if this angle is 75 degrees, then this angle, the corresponding match, it would also have to be 75 degrees. So using this concept, if we know that this corner right here is 125 degrees, you can kind of see that, 125, then identify the other angles. Well, this one down here, angle 7, would be the same measure as this one, 125, because they're corresponding. So the measure of angle 7 equals 125. All the angles that would be vertical pairs, so like this one and this one would be a vertical pair, those would also be congruent. So the measure of angle 1 would be 125 degrees. And since 7 and 5 are a vertical pair, then the measure of angle 5 would be the same as the measure of angle 7, 125. Now, how to find the other angles? Well, we have 1, this angle, 5 and 7, and so how do you figure out the measures of angles 2, 4, 6, and 8? Well, here's how I would think about it. I would say that these two angles right here, this one is 125 and that one that's 2, form exactly half a circle from one side over to the other. And so the sum of those two would be 180 degrees. So to find the measure of angle 2, I would just take 180 degrees and I would subtract 125. And that's 55. So the measure of angle 2 is 55 degrees. And then any angles that would be vertical with that, like 2 and 4 are vertical, they would have the same measure. So measure of angle 4 is also 55 degrees. If you look at these two intersections, here's an intersection of two lines, and here's an intersection of two lines, you can see 2 and 6 are basically in the same position. They're in the upper portion. That means they're corresponding, and as we said in the first postulate, corresponding angles have the same measure. So if the measure of angle 2 is 55, then the measure of angle 6 would also be 55 degrees. And then the last angle is angle 8. 6 and 8 are a vertical pair. All vertical angles are congruent, angles that are across from each other on an intersection. And so if angle 6 is 55 degrees, then angle 8 would also have to be 55 degrees. Now I explained my reasoning in words. If you were asked to explain your reasoning on a quiz or an assignment, you would actually have to write it out because obviously I wouldn't be there, or your teacher wouldn't be there to hear you. Now this proof at the bottom of the page can be done in a couple different ways. I'm going to show you one way to go about it. As we have done before, proofs start with at least one given piece of information. And they have told us that measure of angle 1 is 75 degrees. Now somehow we're trying to figure out how to logically conclude that angle 7 that's down here is 75 degrees. Well, I know that angle 1 and 3 are congruent because that's a vertical pair. And I also know that angles 1 and 5 are congruent because those are corresponding angles. And then I know that angles 5 and 7 are congruent because that's a vertical pair. So really, just by using the corresponding angles postulate and the vertical angle theorem, we can get there. So, I don't think I actually have to involve angle 3. I think I can just simply state that 1 and 5 are corresponding angles and therefore they're congruent, and then I can say that 5 and 7 are vertical angles and they're congruent, and I think that's really all I need. I just want to point out one thing. Do you see these little arrows? That is how we mark two lines that are parallel. So whenever you see the little arrow markings that aren't on the end of a line, they're kind of somewhere in the middle, they're marking parallel characteristic here. You can kind of see that in this diagram up here. There's an arrow here and here. If you don't see those, you cannot assume that two lines are parallel, even though they might look like they are. Sometimes it's stated in words, like in the directions, it'll say these two lines are parallel, but most of the time then they're also marked that way. Okay, so back to the problem. My plan is to use the corresponding angle theorem to show that 1 and 5 are congruent, and their measures are the same. And then I'm going to use the vertical angle theorem to show that 5 and 7 are the same. And then I'm going to say, since the measure of angle 1 matches angle 5, and angle 5 matches angle 7, then by the transitive property, angle 1 would have to be the same measure as angle 7. And then I'd finally be able to state that the measure of angle 7 then would be 75 degrees because I could substitute 75 in for its measure. So that's my plan. I put together all the things I could see on the diagram. You could see there when I was brainstorming, I actually threw this one out. I was talking about angles 1 and 3 and didn't actually have to use angle 3. But eventually I kind of came up with a plan by putting all the things that I know together. Alright, so my first step was to show that measure of angle 1 equals the measure of angle 5 because they are corresponding angles. Then I said I wanted to show that angles 5 and 7 have the same measure. And that would be because they are a vertical angle pair. I don't know whether they called that a postulate or a theorem, but anyway, the vertical angles. Oh, let's call it a postulate. And you know, that word isn't as significant. If you just said that they were vertical angles, I think your geometry teachers would be just fine and they would mark that as correct. And then finally I said if measure of angle 1 equals measure of angle 5 and the measure of angle 5 equals measure of angle 7, then these two you can logically conclude then would be the same by using the transitive property. Okay, so if those two angles 1 and 7 have the same measure, and angle 1 equals 75 degrees, then I can basically say that these two equations are the same, and I can substitute out 75, and I can say that is 75 degrees by substitution. So let's see. If I have 75 degrees equals measure of angle 1, and measure of angle 1 equals measure of angle 7, then the measure of angle 7 equals 75 degrees. Okay. Well, we've already defined alternate interior angles and alternate exterior angles. I talked about this being kind of the sides of a road. Well, the road kind of has boundaries. So if you were driving on the road, you'd be driving here. If you're on the outside of the road, you would be either above that line or below that line if you drove off the road somehow. That was called the exterior area. Whereas if you were somewhere in here, you'd be on the actual road itself. That's called the interior. So if we're talking about alternate interior angles, we're talking about only those angles that are inside the road. And alternate means that they exist on opposite lines of a transversal, or opposite positions on a transversal. Here's your transversal line. Remember, transversal lines are just lines that cross through two or more other lines. So this one and this one, when a transversal crosses through two parallel lines, would have to be congruent. The angles in the alternate interior positions would be congruent as long as the two lines that the transversal crosses are parallel to one another. Exterior. Here are the boundaries of your roadway. Cars would drive here. That would be the interior of the road. So anything over here or down here would be on the exterior. So angles up here and down here are called exterior angles because they're on the outside of the roadway. And alternate means they're on opposite sides of the transversal line. So this is an example. We have angle 1 and angle 8 being in alternate exterior positions. And this theorem says that if your transversal cuts through two parallel lines, that the angles in these positions, the alternate exterior positions, are congruent. They have the same measure. So we can use these ideas to answer some questions. So, for example, number 19. Really, any of these angles, theorems, we can use to solve this. So if I explain it in one way and you were thinking about answering the question in kind of a different way, it doesn't mean you're wrong. It just means that your logic, the rules that you applied to the problem might be a little different than mine. As long as we come up with the same answer, it's okay. So, for example, what I see here is I see a pair of vertical angles. This one and this one are across from each other on an intersection. So a vertical angle pair is congruent. So y equals, oops, that's 110, not 100 degrees. Let me change that to a 1. There we go. And then angles y and x are on the interior part of the road, but they're on the alternate side of the transversal line. So angles y and x are alternate interior angles, like this. Here's the boundaries of your road, and here's your transversal line. So these alternate interior angles would have to be congruent as well, according to this theorem, as long as these two lines are parallel. Are they? Yes, they're marked that way. So if angle y equals 110 degrees, then angle x would also have to be 110 degrees based on the alternate interior angles theorem. Number 19, you have two parallel lines and a transversal cutting through. These two angles are exterior to the roadway. See, this is the roadway, but they're on the opposite sides of the transversal line. So they would be called alternate exterior angles. According to theorem 3.2, they'd have to be congruent. So we could state that 2x minus 4 would have to be the same measure as 92 degrees. So setting that up, it's an equation that's solvable for x, so we can go ahead and do that. If I divide both sides by 2 here, I get 48. Number 21 has to do with corresponding angles. We have a pair of parallel lines and a transversal. These two are in the same spot of this intersection and this intersection. Do you see they're in the upper left-hand corner of the intersection for both? 120 degrees and 3x. So those two, according to the corresponding angles theorem, or excuse me, corresponding angles postulate, either way is fine, would be congruent. They're the same. So 3x would have to be equal to 120 degrees. So dividing both sides by 3 will find us our x value of 40. little relationship was something called consecutive interior angles. So remember, if this is the roadway, the boundaries of the road are those two lines, this would be the interior, right? The inside of the road. Consecutive means that they're on the same side of the line. So this angle 3 right here and this angle 5 right there are on the same side of the line. Now those two are not going to be congruent. They have a different relationship. They are supplementary to one another, which means that if I add up the measure of angle 3 and the measure of angle 5, they're going to add up to 180 degrees total. Measure of angle 3 plus measure of angle 5 equals 180. So, filling in this line in the theorem here, the word we're missing is supplementary. As you can see in example 20, it's trying to illustrate this theorem. We have a pair of parallel lines here and here. They're marked as parallel with these little angles. And these are on the interior of the roadway, this one and this one. But they're not the same amount, are they? This angle and then this one down here are not equal in measure. They're consecutive interior angles. Consecutive means on the same side of the transversal, and they're on the inside part of the road, interior. What are they? Well, they're supplementary. That means that if I add one angle, that's 5x minus 10, and I add that to the other angle, which is 75, I should get a total of 180. That's different than a lot of these other theorems where we simply state that they're the same. Different type of relationship. Adding like terms, I'll get started in solving. I'll subtract 65 on both sides. And divide both sides by 5. To give me 23. Number 18 is also an example of the consecutive interior angles theorem. This angle right here is 68. This angle right here is 2x. These are not congruent. They're consecutive interior angles. They add up to be 180 degrees. So if I add 2x, that's this angle, plus 68, that's that angle, the total of those two will be 180. So finding x is just a matter of solving this equation. I have 112, dividing both sides by 2, x equals 56. Numbers 13, 14, and 15 are a little bit more challenging, but not too bad. I would start with this one. I see the parallel lines here. I see that this angle and this angle are in the exact same position. They're in the upper right-hand corner of their intersection positions. See that? So I would say those are called corresponding angles, and they are congruent. So that means that 5x plus 15 would have to be the same as 110 degrees. So I would subtract 15 on both sides. And then divide both sides by 5. So x equals, oh, I made that wrong. I wrote down the wrong thing in my other piece of paper. Oh, no, it was just a different number 13 that I'm looking at. That's why I'm confused. I'm wondering why I'm getting a different answer. Different question, that's why. All right, so yeah, I'm doing this right. It's 19. Okay. Now, the other thing they want us to find is y, and that is part of the name for this angle right here. Now, this angle here and the 110 degrees have a relationship. They're not congruent. One is big and one is small. But when you put them both together, can you see that they'll form exactly a half circle? So that means that those two together give you a total of 180 degrees, right? Here plus here, okay? So that's a different type of relationship. I'm going to say y minus 28 plus 110 degrees equals a total of 180. So if I add like terms here, 110 minus 28 is 82. And then if I subtract 82 on both sides, I get 98. Now this one's going to be a little bit harder because these two do have a relationship. They are congruent because they're alternate exterior angles, but the problem is I can't make an equation. I can't say 4y minus 16 equals 2x minus 24 because this one has a variable y and that one has a variable x, and you can't solve an equation for two different variables at the same time. You have to get them to be the same letter. So I'll have to come up with some other way of going about this. If I have 68 degrees, that's actually pretty helpful. I'll be able to find some other angles. For example, I know that this angle, 68, and this angle right here, they form half a circle. So the grand total for these two would be 180. So if I, for example, want to find this angle, I would take 180 minus 68 and get 112. Now the reason why I did that is that I was trying to figure out something that I could set equal to either this angle or this angle. And I thought, well, these two are vertical angles, so that would be the same as this one, if I could find the numerical amount. And these two are corresponding angles, so those two would be congruent. So it was helpful for me to find this angle because it would help me set up an equation here and here. So my two equations are 4y minus 16 equals 112 and 2x minus 24 equals 112. Now again, if you did this in another way, it's okay. I mean, this is just one way of thinking about it. You could use the 68. You could add 4y minus 16 plus 68 equals 180, and that could be an equation you could solve to find y. This is just one way to do it that I came up with. So following through with my strategy, I get 128, dividing both sides by 4. I get 32 as my answer for y. And here, if I add 24 on both sides and divide both sides by 2, I get 68. Now, as you can see, I'm kind of running out of space, so I think I'm going to leave off here for this video. There you go.